going to go over that solution. We're going to talk about data modeling tonight. Solution. Actually, I've already put that out there on the iDrive. Now, this is not necessarily the solution that I was expecting from you. This would have been and I'll show you where you would have put your constraint alter table statements. But this would probably be an approach if you were, you had everything together and you were wanting to put this whole thing in a script and you had a game plan for doing everything. And this would be create the table, and then do the bulk insert right after that, and then insert any extra records that you might have. You can put those in, just like you see in the riverbed. The riverbed didn't do any bulk insert, they just did insert things. And so there's a strategy for doing this is you got to start working with the tables that are the most independent. And actually we only got one table that's really independent, and that was the products table. First we thought maybe the office table might be independent, the sales rep table might be independent, but they weren't, or they had things going both ways. Okay. So that one was kind of tricky. So, but typically you can see I did those next. So you start out with the most independent, and then the most dependent is going to be the last ones you do, because those are the ones going to have all the foreign keys that depend on those earlier tables. Okay. So here's the products table, and typically what I might do is go ahead and put the primary key in there, and you can see in this case we had to use it as a table constraint because it was a composite key. I didn't have a choice. But even if I had a choice, I usually prefer to do that because I like to list them at the bottom, and I get to put that nice name on there. It's clear where it's at. So that's just a preference. And so the next thing I would do is import the records from, I call it products import. This is an older version. From a data file, whatever our products data file was, using bulk insert. And then if I had any other records, which I asked you to do, create some new products, you would put them right there. And then I'm ready to do the next table. Any questions on that first one? You want to pull that up, you can see it on your own screen. I got very explicit about the nulls and the not nulls. In fact, I think everything on there was not null in the products table.
What is the advantage of doing the primary key at the table level instead of doing
No particular advantage. In this case, I had no choice. Okay, because I got a compound key.
exactly the
Okay.
next one?
It's a matter of style and preference. I like to put the name, because I got a name on that constraint, so I can go out in that tree structure and I can see it. And I always like them at the bottom. Just me. I like to see everything. I like to have all constraints listed after I listed the columns. You can actually, I think you can actually name those as a column. That way you can just say constraint. Yeah. But I like to put it down the bottom because that starts with running. All right. Any other questions on that?
What is the single and target single mean? What is the single?
Oh, this is, forget, I'll tell you what this is. I realized where I got this. This one was, that's where I got the import thing, is this one was set up to And actually, I replaced the bulk insert with the, with Access. They had a nice table import with it. And you could use that. All the way through. So in there it was single. So you're going to use this.
How many?
Pardon?
Can you use minimum?
Where was I on this? Price?
Not even 30.
Oh, okay. Or you're going down the next one. Yeah, money would be, I'm sorry, money would be better on that. Okay, I'm not there, I'm still looking at the other one up here. Price, I got money on that one.
Okay, I got a question. Your lipsticks after the product, do you need to put something in those parentheses, or can you use the?
Insert, okay, in here?
Yeah.
Oh, yeah, you put the values in there. That was just
Okay.
that was just some blank spaces that you substitute the values in, and
Okay.
you're gonna put all values in.
Okay.
So that it was just an indicator there. That
Okay.
you got specifics.
Okay. Okay.
So if you got some inserts, go ahead and, okay. Okay, and I mean, now offices, that's a pretty good candidate. It's reasonably independent, but it's really hot, okay, as we saw. Then I do that one next, and I go ahead and put the primary key in here. And then go ahead and import everything, and then insert any extra insert things. Almost like the first one. Okay. And then the next one we do would be the sales rep. And now I can start to, I can put a, I got my, these should be okay. I'll, forget, the single there would be money, okay? Kind of. And also the byte, it's a tiny int for you, okay? Byte is a access data type. For us, it's tiny int. That's one byte. And here I went ahead and put my primary key in, but also now I can put my first foreign key in here because I already have an offices table in place. So now I can put the foreign key in there for the office that the sales rep works in. Okay. Now for you, what I ask you to do is that you not try to do that now, but in this case I'd be okay because I already have that in place. So when I do my bulk insert, I'm not going to have any collision. Yes.
In the offices table, there's the manager field, which really should have a constraint to the sales rep field, but there's no way to do both of them and be able to add data.
That's right.
So you just leave the managers.
You have to leave them there, and if you'll note, I'm going to do those in the office tables right after that. Yeah, I can't do it in the table definition.
Well, but even after, like I was thinking afterwards, but basically in the offices field, the manager needs to be in the sales rep, and the sales rep, not in the offices field, which needs to be in the offices table. So what that was doing was basically creating a loop saying one has to be together and
Yeah, and the point is that that's because, and that's what these two constraints are doing. So you had to make sure that you hadn't have those in place yet.
okay, so you lock it in after you add it.
Yeah, you add it in now. If you happen to have that constraint in, then what you have to do, in other words, is to drop that constraint. That's the advantage of having the name. Go ahead and add the record,
then what's the point of the constraint?
Okay, that's, that's when you're doing these bulk inserts.
Well, also when you're adding in the new records.
Okay. Okay. With a new record, then the key thing is that in this case, what you have to have is that you have to be sure that the supervisor is in there before the person that reports to him. That's where the constraint is. But he would try. In other words, we've already assigned you the supervisor, but we haven't inserted his record yet. So what happened? I went looking for
So
it.
just don't put an office to the supervisor.
No. You gotta get him in the right order. You have to get him in the right order. Yeah, that's, you gotta be real careful on those. Is that clear for everyone? No? Okay.
I don't think we understood the question.
Well, the question he had was, he was having trouble getting records into the sales rep table, and the reason he would, and this was on this constraint that looks like this, okay? Is, remember last week we had the sales reps, and we had this constraint, okay? Self-referential. Okay, what this constraint does, this actually creates a hierarchical chart. So if you actually, put out these names and you kind of drew a little chart on them, here's the top boss, and here's maybe a couple of supervisors. They report to him. He's got to be in place first before you can insert these guys. Okay? Because you're going to refer to them. Okay. Now, the employees for these supervisors, okay? Okay. I have to have this guy in place first before I insert these. Okay. And if I do it in that order, I'm okay. The problem with the bulk insert, you don't know where these records are. So what you have to do is that if you had had these constraints in, you would have had to drop them. Okay? Go ahead and do the bulk insert. Then add them back. When you add them back, if you had something that didn't make sense, it catches it then, because as soon as you add this constraint back in, it goes through and does a table scan and does a check. Okay? It's kind of ugly. And so, that was but you do it, and then you can actually, build a transaction says then all of these go together, and they all work or none of them work. And we'll look at something like that near the end. Hopefully we get that. Get time for that. Okay.
I have a question.
Yeah.
When you do your diagram, you won't see the manager on your diagram. When you print them out.
You won't see the manager. What do you mean you won't see the manager?
You see sales rep,
Yeah.
okay, and then in that little box that you have behind it, is that gonna show?
Oh, that's not a little box. That's the line.
Okay. So
Yeah, you
that's the
see-
managers.
Yeah, you see. Yeah, it doesn't come out and put them in the. It doesn't.
In the
It doesn't draw right from the. In other words, if your employee was right there, and then or your employee number's there, and your manager's there. Okay, this is an employee. It doesn't. You think, well, it would. Come down here and point stuff like that. No, it just puts them there and it indicates that it's self-referential.
Okay.
That's this line right here is just like a line between two different ones.
Okay.
That's all it is. And you should see that on your diagram. Okay. So in this case, after I've got this offices table and after I've got the sales rep table, and then I've got these two constraints, which is a result of the interaction between the two tables, all right, and, well, between the two tables and the one table itself, then I put these in. Okay? Is that clear for everyone, what we're doing there?
So then it's back to order, not if a check or no check.
Right, well, now that's a different thing, Rick. What you're doing there is that that has to do with the values on the fields. Check or no check.
I think we were just thinking because they already had duplicates, but we were trying to make them the key.
Oh, I'm sorry. Okay, I'm sorry. You're not talking about the check constraint. You're talking about putting there's a flag in there on, when you insert it, it says, don't bother to check to see if there's duplicates.
Right.
Yeah, yeah. Yeah, normally you don't want to do that. Okay. Because ultimately, that's the way to corrupt your data, because that way you've got duplicate. But there may be some special cases. You might do something like that, but I'm not sure what it would be. Yeah, I see what I misunderstood your question. And that was what you were having trouble with.
That's what, yeah.
Yeah. And Stephen probably didn't do no checks, is that right?
Oh, at one of them I caught, he done no check and I done check, and I think that's my.
Yeah, that's why you had the problem, okay?
I just didn't catch what we had.
Okay. All right. Actually, it was cheap.
Well, that's the problem.
That's what it
That was the way to make it work.
Because huh? Well, yeah, you kind of sort of got lucky on that. So. But here it's, this is I refer to this as a strategy that'll get you the right results in the end. Okay, and then the next most independent thing would be the customer. And in here I can put in the customer field, and I'll put in the primary constraint. And also, since the sales rep is already in place, okay, then I can go ahead and add the primary key constraint. And then go ahead and bulk insert the data and any other additional insert. Okay. Any questions? And then finally, when you get to the orders table, you shouldn't have to use any alter statements at all. But it's completely dependent. So you just go ahead and put all your constraints in. And you can see on this case, I got, excuse me, I've got 4 constraints. Okay, so we got the primary key, and that's the order, and then it was placed by, okay, in this case, a customer, and it was taken by, got carried away with this, okay, by a sales rep, okay, and that's already in place. And then now for our product, and we had a real doozy here, and that was again a foreign key that has to now be a composite key to match the product table. And then you can go ahead and add your stuff in. Okay, any questions on that?
Where do we find that solution?
It's out there, it's in last week's folder,
It's on the iDrive Build DB solution.
and it's in the last week's handout. I didn't, I don't mix them up, I'll put them in with your stuff, if you would, where the program was assigned. All right? Any questions on that?
What did you say, single is, converts
Oh,
to
it should be money.
money?
Yeah, in this case.
Money or small money?
You could be small money, because I don't, well, I'm careful on the target, that might be greater than $214,000 or something, so,
Okay.
not that. A product item price, that could be small money. I don't think we've got any big ticket items in
Would it be at all feasible to have created this database in the tables first and then go back in and use an alter statement and add the constraints?
here. No, that's what I'd ask you to do, that's perfectly fine. Nothing wrong with that. What I've done here, I just gave you an example where where I had alter statements in here, I really had to have the alter statements. Okay. And if I plan things very carefully, then, most of my constraints could be, right there in my table definition. But in the case of, where we have that right here, that's because of the nature of it. We got two relations going, to each table, one going one way, one going the other, and then we have this self-referential here. Okay. So there, it's easier to bulk load that data, then go back and add the constraints, and then if you got something wrong, then it's gonna stop wherever it found the error. So it's going to do the checking. So the data is already in there. Okay, it's just coming back and giving you the notice of the error. So you have to fix that. That's the easy way to get that done if you're in that situation. But in this case, I would have never had that problem because I was very careful what I did. Good. This is not particularly easy to do that, or we could just start it. You gotta really be thinking about it, so you get things in the right order. Okay. Any other questions on that? So you can compare what you did with what this is. Not quite a one-to-one comparison because I got some data types in there that don't match up. Yes.
If some of your tables don't have primary keys and can you alter it later?
Yeah, you put your primary key in with an alter statement.
You have to put it in before you do anything else. I mean, you can't do references if they're not.
No, you don't have to. What happened is that if you put your primary key in an alter statement, after you've bulk loaded, then when you do add that constraint, then it'll go through and scan your table, and if you had some duplicates, it's going to flag it for you.
See, I'm getting an error that when I try to link two of my tables together, it's telling me that there is no appropriate key in the other table, even though I've checked and rechecked, tutor checked. These tables, the names, everything's correct, but it says that these aren't in there, and I don't know what it is, whether it's a primary key or what.
But it should be a primary. You'd have to show. I'll have
Okay.
to look at that.
Okay.
That's a specific problem. If you have a primary key constraint in there, and then you're referencing that, it's probably telling me you just got an error in your foreign key constraint, referencing that primary key. You go in there and look at that. spelling on something, or something like that, we can change it for you right away. Okay. Any other questions? Put that away. Okay. We're going to talk a little bit about data modeling. Okay, again, probably put a disqualifier on this. Most of you probably, this will be the last time you'll do data modeling. Or typically that's not, these are usually specialists that do stuff like this. But it's good to know that process, and if you have an occasion that need to do something like that, get some understanding about what's going on, then you can do it. And I like to do this because first of all, I think you need that exposure. Secondly, going through this process and actually going to create a little database gives you a better insight into probably later on when you will do your query. Get more insight and understanding. Probably now you seem like maybe some of the queries you seem like you're doing magic for, but hopefully, after doing this exercise you just did, you start to appreciate, what those constraints are doing for you. And now we're gonna see that the importance of having those constraints. Because one of the key things about creating a database is I want preserved data. And I want to be able to get to it. And sure, it's easy to get to our stuff now because you get in a bind, you just show the whole table and look around and see where it's at. But when you're talking about millions of records, then all of a sudden you have no idea. So the only thing that you can do is to have a good discipline for being able to organize it and then get to it. And that's what these constraints are all about. So we're going to look and see how we implement the semantics into our tables. In other words, the meaning into it with these constraints. Okay, not just the syntax to make the compiler behave. So this is going to look kind of like magic, but you get to have a little bit of appreciation for it. All right. So what it is, it's just a process of modeling and formalizing data requirements. So somebody has said, build me a database, and usually they give you some kind of requirements, and they're pretty loose. Actually, they're not, but if you were to go into a small place, and they'd really be loose. Okay, bigger organizations have got some processes in place for that. But you have some kind of way of formalizing the data requirements, and it's usually being able to organize my data into some tables. And this is, I think this is the part that's good for us, help us to understand the complexities of the real world environment of managing data. So it's going to help us to manage that process when the data gets large amounts. Okay. The way we're going to implement this data model is that it's going to be implemented as tables, columns, relations, and constraints. We're going to have kind of a simple graphic modeling here, but ultimately we take that little graphic model and we're going to implement that in tables, columns, relations, and constraints. And now you've kind of done this from the process of I had the data for you, okay, and so you really did it from that perspective. Now it's, what should we even say? What should we store? And that's what we want to model. All right, so what are the characteristics of the data model? Okay. There's this notion of referred to as an entity. Okay. And what an entity is any object about which data is stored. The example in what we have. The salesman is an entity. Okay, the office is an entity. The product, the order, the customer. Okay? So we would talk about, that's what we want to store information about. Okay. And if you'll recall, that was implemented as a table. And specific instances of an entity, it's a row. You had particular products, you had particular customers, you had particular salesmen, okay? Okay. And the characteristics would be those things that would be described as columns or the fields. And we implement those as columns in tables, or we click on this, fields in rows. It's really a straightforward process. Okay, now the association between entities. How do they relate to each other? Yeah. And the way we establish that relationship is that foreign key constraint. And this is the part where we get the semantics. In other words, you know, a customer doesn't relate to an office. Okay? That wouldn't make any sense. Customer doesn't particularly relate to a product indirectly through an order. Okay? And so the idea here is that I've got these entities, how do they relate? Okay? And we establish that relationship with that foreign key constraint. And we decide what that should be. That's what's referred to as the semantics. Okay? Okay. Now let's further refine that semantic content. Okay. Now there's something referred to as the cardinality. So any of you get real interested, there's whole books on this stuff. And you're only going to want to do something like that if you're going to do professional type of work, or if you got into MIS programs. You have an MIS course and all that stuff. You're a business analyst, but you got in the back door, right? Okay. Well, right now, if you were to go over here and do a little MIS course at UTD, you get a pretty big dose. All right, so just the way we have mappings, and just give you an example of a mapping. I'll do it with examples here. Is we have things called one-to-one, one-to-many, and many-to-many. And I'm going to go down here. The most common is the one-to-many. And it might be an example here. I have a customer. Okay. Customer. And we have things called orders. Okay. And there's a relationship between those. And there's a relationship that a customer can place an order. Okay. But a customer can also have more than one order. So every customer could have one or more orders, and I usually indicate that on a diagram with what I refer to as the crow's foot. Okay, there's different notations. So I'm gonna use the notation here I'm using is the James Martin notation. So I don't imagine anybody in here has not gray hair to remember James Martin. You might, but you know what? You just got the gray hair, but don't remember it. Okay, all right. So he come up with this modeling. That this was the '70s version. So most of you are not going to be around in the '70s or something like that. So and so that's where it came from. James Martin. And it was also the modeling process used for the Texas Instruments information engineering facility. It was a modeling tool that would develop your model and then generate all of your code for you, your queries and everything. The COBOL statements and all. Okay? And so, pretty impressive product. Okay. So, this is an example of one too many. Okay. One too many. Okay. An example of, I could have orders and products. And so I could have an order could be for many products, but a given product could be on many orders. Okay? I can have an order that could have an order that could order one or more products. But a given product could be on many orders. Many active orders, let's put it that way. Okay. Well, this is a many-to-many. Many. And that's what you had that semantics in a model. You say that's fine, that's descriptive of what it is, but we can't implement that with tables. We've got to do something else. And so when we have a situation with many-to-many, we have to convert this to two one-to-many relationships. We're going to have a little example of that tonight. We'll do one exercise. And sometimes we have something here with orders. And then we've got our products down here. I made your homework assignment easy. It's only had one product per order. Okay, so that was easy. Okay. We have to put in another table here. And sometimes this is referred to as a link table, but it usually has meaning. Because what this is going to refer to in this context, it's going to be our line items. Okay? Line items in an order. And on that line item will be a product. One product per line item. Okay? So now our orders, I'll just use the term line items in here because that's easy. So our orders can have one or more line items, meaning I can order one or more products. And a product can participate in more than one line item, but on different orders. Okay. So you can see what, now this we can implement. So something that we have here was we would call two tables. I can't do that with this kind of a relationship. So what I have to do is I have to create this third table. And quite often it makes sense because there's information that I might have on that line item, like the quantity. Okay, a quantity number. Yes.
So should you always avoid many-to-many?
You don't have, you can't avoid many-to-many. It's what is in the meaning here. Now, what happens, you don't implement this. what you'll end up is implementing this. In other words, if we had this situation, somebody says, well, I want to keep all my orders in one table, and I want to keep all my products in one table, and you're going to come back and say, you're not going to do that. You're going to keep your orders in one table, your products in one table, but you're also going to have this table. You have to implement this table. You have no way of creating the fields in there.
So what do you call it?
This right here?
Yeah. what you do.
I don't think there's any particular name for it other than resolving a many relationships into two one-to-manys. There's no magic name for it. Other somebody might already invent it. But that's what we're doing.
We did the same thing in Access Database.
Yeah, same, yeah. Okay. It's not related to our database at all. This is just related to creating a database in any database system. Okay. A one-to-one. Okay. And there's not too many cases where there's a one-to-one, and one that I might think of is I didn't think of a good one now.
I've read in a book somewhere that they're rather pointless.
Well, no, they're not pointless. Pardon?
For security, like social security number, would be.
A good one would be we're gonna keep a high level table on a person, and then there's another table over here called person detail, and this is more of a database convenience, but this might be only the high level stuff on the person, but there's a lot of detail on a person. So for every person in here, he has another record in here, and there might be let's say 8 fields on this person. That's the essential stuff. Your name, your address, your birth date, something like that. Over here would be something like your social security number, because this could have some security on it, and a whole bunch of other stuff they have on you. Okay, like all of your everything, all of your salary history and everything like that.
And maybe for security that would be good, but they say generally they say that it's a bad design because you could all be one table. There's no point in making it 2 tables.
It could be, but actually I'll argue that it's probably bad design to make a great big table that has only a limited number of fields that would ever get access. So this would be for high access. Okay. Smaller table. Don't forget, when you access it, it's a table scan. No getting around it. Top to bottom. Okay. Here, with a lot of detail, low access. Occasionally we got to get in and find out about you. Okay. Is that clear for everyone? And so, yeah. The point here, you don't have too many of those. It's almost going to always be, well, ultimately it would always be one-to-many. You'll have real many-to-many relationship, but you actually end up converting those for implementation into one-to-manys with a linked table. Okay. Is that clear for the one? All right. Let's express. An optionality. These are actually terminologies here, and I'm not gonna, I don't think I'll quiz you on this stuff. I might. I'm gonna say that, because otherwise everybody will start to zone out, like going into Facebook. Okay. Expresses whether or not an entity must have an association with another one, okay? It actually creates a dependent relationship. Now, example. Okay. My customer, okay, my customers. I got my customers, and I got my customer database. And then I've got my orders database. And I got the crow's foot there. A customer at any one time doesn't have to have orders to be in the customer database. Okay, so if he doesn't have an order, then we don't see a relationship on that. Okay, it'd be like we're going to ask the query, how many of our customers in the database now don't have an order with us? We want to, we're going to, you remember the exercise we had on that, doing the outer join? Okay, well, we want to send a flyer out to them and say, we got a good sale coming up. See if we can get them to place some orders. Okay. So this is this right over here, and typically on the primary key side, it's always going to be optional. I call it participation. We call it the optionality. But in the case of an order, and this is usually the symbol they put there, we just leave it off because it's usually implied. It's not optional. If you're not a customer, we don't put any orders in here. Because we're gonna have a foreign key in here that's got a match. It's up here. Yes.
What's the line that you did
Oh, you mean this?
Yeah.
That's indicate mandatory
Oh.
and mandatory. If I was really doing the diagramming stuff, then I could say, put the little zeros up there for optional. We just leave that stuff off because that's usually implied. And that was typical of the James Martin IEF methodology. So we're not going to put those in there. It's obvious. Okay. Well, there may be some situations where we need to do some enforcement with those limits. What we want to do is be able to translate what we have on here into something that's going to be in our strengths in the database. Do some yes.
When you said on the primary key side, orders has a primary key.
Right, it has but in this relationship,
From the one to the other.
Yeah.
Okay.
the foreign key has got to relate to a primary, and I call it the parent or the primary key side. This is the child or the foreign key. That makes a good mesh. The child's supposed to be dependent on you. Then they have some other ideas. Till they go, well, yeah, one way or the other. They go hungry and they know where their food's coming from. All right. Okay? So that's a high-level view of that. Okay. Mandatory means the entity must participate in the relationship. Okay? And orders has to participate. Customer does not. Okay? So this whole business of mandatory produces an existence dependency. In other words, I don't have an order if you're not in that relationship. I don't have an order if a customer hasn't placed it. And we're going to enforce that. We're going to see how we enforce it. So you can't put a record in here for an order if you don't have a customer to match up. Okay. This simply means it's not required to participate. Now, and what we'll do is that we might get a set of requirements, and somebody says, I want a database, and so the first thing you do is you kind of look and create this entity relationship diagram about, what are we going to keep for you, and what's going to be the relationships, the big high-level picture. And then after we get the big high-level picture in place, then we'll go and start to say, what should these tables look like, and how do we connect them to get the semantics. That's the key word here, the semantics, the meaning of it. Okay, the parent table. So, and incidentally, in general, unless there's some special relationship, every table that we have in our database, it better be related to another table. That's the idea. We just don't have a bunch of collection of tables, by the way, look at all these tables we've got. Now, usually your customer might have that view of it, but as somebody who's going to create the database, no, we're not going to do that. We're going to make sure everything is related, because that's what would give it the meaning. Okay? We'll talk about, we'll kind of draw a little generalized relationship entity part. And I'm going to refer to something called the parent table. Any two tables, the relationship between the tables is the parent and child. I'll use that. And I'm just going to put the line in there like that. In general, it's going to be, I guess, probably safe to do that. All right. All right. So in a parent table, it's usually sometimes also referred to as the reference table. And what we mean by it being referenced is that this is going to refer to this. And this maybe a little too generic for you. Customer. This is easy. Customer. Orders. I got an order. Who does it belong to? Okay. That's what we mean by referring. Okay. How it refers to this, okay, is with, I'm going to say a primary key, because that's going to be the normal thing. Is that the only requirement in a database system? No, it has to be at least unique and not null. But I think in terms of practicality, okay, real world stuff, it's going to be the primary key. You're not going to do something esoteric because you can do it. Okay? So when I have primary key, that will be unique and it will be not null. Okay? Any questions on that? Okay. Okay. The cardinality is 1. It's always 1. The same right here. Okay. And it's always optional. I don't have to participate. Any questions on that? Okay. The child table. What are its characters? Okay. That's this one down here, corresponding to orders. Okay. It's always the referencing table. In other words, the one that's referring back to something. Who do I belong to? Who do I depend on? Okay. And that referencing column in there, so that I know who I should be looking at up here or referring to is the foreign key. So you can see how we're getting that semantics in here. In other words, this foreign key, primary key relationship is going to enforce some semantics for us. I'm going to put the meaning in there, okay? And this is it. It does that. It is a constraint. Probably the most important constraint. And a primary key constraint is dependent on you having a primary key constraint in place. And you want that. Even though the minimum requirement is what? Unique, not null, but don't do that. If you get to do this sort of stuff. Okay, any questions on that? All right. Okay, how do we enforce that cardinality on the child table? Because this child table down here, on the parent, it has no meaning in the accident realm. But on the child table, I could have, I'll get another comparison over here. So the only two that we can really do, we can't do many to many, okay? So, how do we enforce it that says this is going to be just one, and this is one or many? Okay. And the way we enforce that is by putting a unique constraint on that foreign key. Now think about this a minute. If I said, customer, you can only have one order at a time. We don't want to get confused. Okay? So if we say customer can only have one order at a time, in other words, his diagram relationship's going to look like that, then if we put a unique constraint on the foreign key, then what does that do?
Every customer and file and order database has to be unique.
Well, yeah, but what would it do on the order?
Well, every order would be unique anyway.
Right.
One customer.
I could only have one order in there, couldn't I? Because if I start to put another one in, it says, wait a minute, that foreign key column is what? Unique. So now you've got two duplicates on the same customer? No. Okay. See how that works? So what we'll do is that we don't do anything, so we can have as many foreign key references in here to a customer up here. That's what gives us the many. You see how we enforce that semantics? By putting this on the foreign key. It's all in this foreign key relationship. We're going to get all of our meaning. Okay. Is that clear for everyone? Really subtle. So if you want a one-to-one, okay, that was like the person and the person detail. Okay, there's only going to be one person detail record over there. We don't want two. Okay. So that foreign key column in there would have to be unique. All right. Okay. Optionality. Okay. So how do we make this mandatory? And that means when we make it mandatory, that means we're gonna create a dependency relationship. Okay. To make it mandatory, we're gonna say that foreign key field has to be not null. Okay. Has to be not null. That means I gotta have a legitimate primary key reference in there. If I allow a null, it says, hey, I don't have to put anything in there, I just leave it empty. Cool. We'll have a bunch of orders in there, but they don't belong to anybody. Okay? Doesn't make any sense, does it? And I don't have a dependency relationship. So when we enforce mandatory, we got to put not null. So you'll note that on all your foreign key columns, you're always going to put not null in there. Okay? And if you want it to be in a one-to-one relationship, it'll be not null unique. Good? This one null value is unique in a unique column constraint, believe it or not. A little strange. Okay. Any questions on that? Clear? Sort of. All right, so all of our data semantics is determined by the foreign key constraint. And it's really determined by the foreign key constraint gives us the relationship between the two tables. And then further, it's the mandatory and the cardinality is determined by the not null and the unique constraints. Okay. Okay. Any questions? I don't think this is in the bureau. Okay, let's do another example, and then we'll do a little practice here. Premier products. Okay, let's go through a little process here. Premier Products is a distributor of some appliances, housewares, and sporting goods. And they're a pretty small place, and so they decided they'd hire you to come in and create a database for their stuff. And they would like to maintain information about their sales reps, okay, and and their customers, and their orders, and their inventory. Okay. And in this case, our orders, they could have more than one thing. They're going to let you buy more than one thing. All right. So this would be the problem that was presented to us, and they just hired you to construct the database, and then probably got this information in some kind of strange files. And that's where the dog work starts, but here's the high-level design stuff. And the first thing you do in a problem statement is start to look for the entities. What are the entities? Kind of giving you a hint, haven't I? Provides you a little bit entity. Okay, now I'm going to write them over here, but basically, you got what, 4 in this little database, don't we? High level. Okay. So we just start. We have to decide how these are going to get connected. But first, I'll just might even put if I was doing this and I had a whole bunch of them, I'd get some of those little yellow sticky things and put names on them and put them up there and kind of move them around. Decide how do they all go together. But I think we can do this one first. So here's our sales reps. Okay. And what else do we have? We got some customers. Okay, customers. And we got some orders. And we get orders from the inventory. Okay. something from the inventory. All right. Probably, you guys got a little experience now. So you start looking at. Well, at least, I guess probably, it depends on, how they want to discuss this, but at least they may say, that we may have we could either have a sales rep that assists you with the order. Okay. We'll see if this is the case. And then, and we might have a customer that places the order. And then we would have what? An order could be for many things in the inventory. And many things in the inventory could be on, any one thing on the inventory could be on many orders. Okay. That's the semantics in the meeting here, but, immediately when we have this many to many, then we say, wait a minute, I can't implement that because I'm starting to think about how do these get created into tables. So usually at this point, I don't leave it like that. I do this. I do this. So I'm a lot of space here. I'll come over here. I've got line items. Okay, line items. Line items. And so I have an order. Okay, an order can have many line items. And an inventory can participate on many line items. So I've got to create 2, 1 minute. And our sales rep, he can place many orders, assist with many orders, but only one order is done by a sales rep. And each order is done by a customer. But there's only one customer related to that sales order. So this would be my what's referred to as my ERB diagram, entity relationship diagram. So I've got my real high level picture, and immediately that's mandatory, that's mandatory, mandatory, and mandatory. So we already know what that's going to mean for us. Okay.
Is there the assumption that the customer can only make one order?
No, a customer can have more than one order.
Yeah.
Okay, wait.
He just changed it to many.
No, I didn't do that. An order can have, a customer can have one or more orders, many orders.
Yeah.
But an order here can only have one customer on it.
Right.
That's what that means.
One order has one.
Right. One customer can have many orders.
Could the sales rep have more than customers?
I didn't put any relationship in there. It depends on the way they would be set. The example I gave you to work on, I really copied that.
Okay.
That would be like, I did say a distributor here, so that might be an indicator that, you got accounts or something like that. But I'm going to assume that maybe it's not in this case. But if it is, then you gotta go back. Something in here. So then a sales rep would have serve many customers, have many accounts, but an account for a given customer, we serve a sales rep. If that was the case, then probably listening to the sales rep, placing the order for a given account. So this one is not do that. So actually, it'd be the four orders. be associated with the customer, the sales rep is the one that assisted you, and he's the one who's always assigned to you, so you always work through your customer. Right. So it could be this or this, but they're not both. I copied it in your case, okay? Just to make it. Oh, no, it's just they're really, you know. Yeah, make it ugly, yeah, well, I did do that, okay? And so you got a lot of exposure to different things. Okay, so, yeah.
If customer places order through sales rep, then would the customer still have relationship with the order?
Right, because it's for a given customer. So you might want to say, you might go and do a query on the database and say, what orders does this customer have? And you don't want to have to do a circuitous thing around and say, well, let's see who his sales rep is to find out, you know, if they placed the order for you.
Why would that not be the sales rep and the orders relationship? The sales rep and the orders?
This?
Yeah, that also should be.
Not necessarily.
Uh,
Because what we're having here, it depends on the meaning of it. In other words, if you always have a sales rep, then whenever you place an order, your sales rep's going to be on it because he wants the commission.
Okay, so sales rep will connect to the order.
No, it already goes through here. You're already assigned that, so you already have that. You wouldn't have to do that. That would be unnecessary.
Why do you have that bother you?
I just said that was, I think the way I got the problem set up, that this was my view of the solution, and she asked the question, could it be this over here? And I said, yeah, it'd be looking like that, that's all it is. So, one or the other, but not both usually. All right. Okay, so our task within that first step, create that diagram, and then create the tables. And usually what I do is I'm going to give you a little skeleton here. I create the skeleton of the tables, and what I put in this table is just a primary key that's an identifier, and then create the relationships between the tables. And when I do that, then I'm going to go through and put foreign keys, okay, in the dependent tables, so that I can quickly look at and get me a diagram and say, does all this make sense? Then I can go back in, this is just preliminary design, then go back in and really create the tables with all the fields and everything. What are we going to say? What are we going to do? And I'm going to give an example of that. So this is what we might have done for the 3 meters, okay, the tables. And so, okay, I called it parts. Parts is inventory. Parts. Did it look like? And this is out there on the hard drive. So in this case, I've got I just got PNOs, high level design. And I got, that's the primary key identifier. I got not null in there, and that's because probably when I did this, we were back in SQL Server 2000, and then I think it was for 2005. You could have a primary key, but it had an ugly glitch. You could have one null. Yes, because it's unique. And so you used to have to, even though you're going to call it a primary key, you had to put that not null in there. You didn't want that. Okay. And then I added the constraint. Okay. Now it's a primary key. But today you don't have to do that. Okay. So I've got my parts table. You'll note that I'm starting with the most independent sales rep. Okay. And he's independent. Same thing. All he's going to have is a primary key. Okay. If you look at our diagrams here, you can look at, okay, 1, 1, and 1. Okay. And so we got one more, it looks like. Sales rep, oh, we haven't got.
Should we use that not null?
You don't have to now, unless you're, working in some place that still uses 2000. Should be. Okay, customers. Okay, I'm gonna go ahead, now here I went ahead and put some constraints in here, but I'll have to see what I did. Okay, so I got a customer number, and looks like, in my case here, looks like we have okay, so he's got a sales rep assigned to him. Okay. So in this case, so we've got this in here. So we'll assume that for some reason we did that. Just to match up with my table. So sales rep can represent more than one customer. We'll see what we're doing here. Okay, so I got a customer number. Okay, this R number is going to be a foreign key. And you can see here's my constraint, primary key constraint. Okay, that's the customer number. And then here we got the constraint, foreign key. Okay, got rep number. And it references sales reps R number. There's a relation right there. So, F, K, R, N, O. Okay. Any questions on that? Okay.
So that would make it mandatory.
Yes, it sure would, because we got a not null on there. In other words, you have to be represented by a sales rep. Okay. Good observation. We did a nice thorough job on this. Okay. All right, here's the orders table. Okay, so yes, there's an order number, that's primary key, and it's probably going to be a good one. I don't have it in there, but an identity column. Heck, we just need a unique sequence number, starting sometime and then never to be repeated. We got our customer, right? All right, there it is. Mandatory. It's got to have a customer to place an order. Okay. And here's our primary key constraint, and here's our customer constraint. Okay, references customer.
I know identity is a repeated, we just implement it each time when a new one comes along.
Yeah.
So when the book talks about indexes,
Okay, now index, okay, what an index is, that's different. Anytime I create a primary key constraint, a unique constraint, or a foreign key constraint, an index is created. What an index is, that's another table. Okay. So you don't take these things lightly. You're creating resources. And primary key, that's appropriate. Foreign key, that's appropriate. But don't get carried away on unique keys, okay? Because those get indexed. What an index is, and that's the way it enforces it. So every time I have a constraint, these indexes, and we'll see that it automatically does it for you. An index is nothing more than index of, gosh, just a list of the keys. Now, it may have some, it may also have a reference to a record, but I don't think it does. And the idea here is that when I go to insert a record, okay, it's gonna go down and look in this index to see if you're gonna have a duplicate. And the reason you want it long and skinny, fast, very fast. It's gonna be sorted, so it can do a binary search and log in time. Log in is as good as you're gonna get. And it's going to be, ideally, you want your keys to be integers, because that's the fastest data type to work with. So you don't want to have characters as a key unless that's just absolutely necessary. And that's the way it enforces it, because you just got to put that in there. Well, how could it enforce it? Well, it could do a table scan. Not smart. That big table. So what does it do? The price you pay is this extra little long skinny table. And if you don't have an entry in there, then it goes ahead and puts that new entry in there, and then it goes ahead and puts your record in.
But that's behind the scenes.
Behind the scenes, you don't have to do anything about that.
I said we're going to foreign key. You're saying there in the diagram that it's on O, but then in the code it says CO.
No. The foreign key, this is for orders.
Oh, okay. Oh, I see.
Yeah. Okay, did I answer all the questions on these? Okay. And then the order lines. Okay. And again, now, the order lines has got to have a order number and a part number. So there's going to be two keys there, and there's two foreign keys. Now, there is an important need for using a unique constraint now, because what we want to do is it's now serving as a unique record, the two together. So what I don't want to do is have duplicates in there on the same product. Okay, well, if I want one order number for that product, okay, we'll put the quantity item on there. We don't need to have, duplicates in there. Say, well, that's the way we'll do the quantity. Does everybody follow that? No. In the line items here, you're going to have, I don't want to erase my diagram there. I don't think I got any space over here. All right, look. Okay, I'll do it right here. So here I have my line item table, line items. And I've got order number, and I've got product number. And usually I'll have a quantity field in there. That order number in here could be repeated, okay, because I can have more than one for another. The product number in here can be repeated. It's the combination that we don't want repeated. Okay, it's the combination. Because we only want one listing in there, and if you wanted two of those, then you put two in your quantity field. Don't put two records in there, and then figure out how to sum them up. Okay, everybody follow that? So what you're doing is that is on this composite field, composite foreign key field. Okay, Because you got two foreign keys right here. The orders, the parts. It's a link table. That's where they get that term link. Two foreign keys.
Why do you
Okay?
make it a foreign key?
Pardon?
Why do you say unique instead of making it a foreign key?
It is a foreign key. Right here. But it's the combination that I want to be sure that I don't put in duplicate records.
I mean, why wouldn't you just combine them and make them a foreign key, like we did before?
I can't because they come. They're referring. I got one that's referring to orders. I got one that's referring to parts. I don't have two fields that are referring to one other table.
So that's just preventing you from duplicate order
Yeah. The combination.
combination.
There's no printer.
No, don't need one. There's no particular reason. Okay. I get the uniqueness here. And I don't want to do that because as soon as I make something a primary key, behind the scenes it's going to do some more overhead type thing. And a primary key produces a very special index, and it's one that's always sometimes referred to as clustered, and it'll be sorted for sequential processing. And so here I could, somebody says, why don't I could make that a primary. Yes, you can do that, okay, but it's probably not wise and not necessary. This is the minimum requirement that we need, and we're going to do that. And we got the not nulls on here, so we're covered, so we don't get any silly records in there. Okay? And that's what we want to do. We want to do the minimum. You've got to, yeah, because you don't want to unnecessarily. But this would be an important constraint. So, yeah, because if I have duplicate records in there, then things are not going to be very nice. So I handle, and this is a good purpose for the link table. It's usually, when we have a link table, we have a many relationship. There's other information that we want to store that's related to the relationship and not either this table or this table.
When you say quantity, are we referring to the number of
Product items.
product items?
Part.
Or how many orders we got?
No. How many parts? It's going to be a given part.
But it will be one order for this particular product.
Right.
But how many of them? Yeah.
The quantity item right here
Yeah, the quantity refers to the products.
Parts.
Okay.
on the order.
So is that considered a unique composite key?
Yeah, it is composite. Yeah, right here. Two. Okay. Any questions on this?
The
Yeah.
unique is referred to, that's a constraint.
That's a constraint.
Is it also a key?
It turns out to be because it's unique.
Right.
It's just not a primary key.
Okay.
And remember, a primary key meaning here in this context, that's a constraint, that's a special constraint. Unique, not null, gives me the same uniqueness as a primary key, but unique does not give me the overhead that a primary key gives.
So the reasoning is we don't need to go add it.
Right, we don't need to do any more than what we have right here. This is sufficient.
Really just keeps the other tables straight.
That's right.
But if there's no primary key, then you get a primary key to the left.
I'm not.
You usually go through
Look
another table.
at this. This is a totally dependent item. Totally dependent on orders and on parts. That's all it is.
So to get into it, you're gonna come from one other place.
Yeah. Exactly.
It's not a standalone table.
No, it's not a standalone at all. It's wholly dependent. And it was contrived because we had to do that because we really had a many-to-many relationship between these two tables, and we said, hey, we can't implement that. And this really makes sense anyway, because most likely we need to store other information about it. In this case, the quantity example. Any other questions?
We could also reference verify quantity exists.
Yeah, that's gonna be, you're getting ahead of us a little bit on that. We do all of this stuff, I mean, when we start placing orders and stuff, to place an order, we have that all in a stored procedure.
Check.
And what we say is, you're gonna place an order, but first of all, we'll check and see if we have enough quantity for before we insert the record here. Is that what
But
you're?
that would be where you would do the checking.
Yeah, that's where you do that, not here.
And then when the order's created, then you would adjust the.
Right, yeah, you go down and adjust it, and then you do all of that stuff. That'd be the case of what we refer to as a transaction. All of that gets done or nothing gets done. It's all gonna jive.
All that's in there, so there is a way to test it out as you
Yep, yep. Right here, we're just gonna create and store things, and we're just gonna have the mechanism in place so that you get ready to place orders. This is gonna be a pretty static table. Customers, we hope, increasing. And our inventory of parts is always changing because we're adding new things and selling things. We've got to add more items, more quantity. Just the orders and the line items are most volatile. As soon as you're shipped and complete, and then it goes to an invoice, and after that, they once you get paid, it goes away or goes to an archive. So this is very volatile. Okay. What else? Okay. Just one common statement here. I'm not going to go into normalization. Again, there's big chapters and big stuff written on it. The bottom line for us, when we create tables, the bottom line is we want something what we refer to as third normal form. That's mathematical stuff, or database mathematical stuff. And it simply says that every non-key column, that means all of your columns in a table need to depend on the primary key. It's just another way of saying that if I store you into a table, everything that we keep on you should be about you and not about something else. Plain and simple. Same thing with products. I got an identifier for the product. The stuff I'm storing on the product should be nothing about the product and nothing else. It's that simple. And if you do that, then you don't have any problem. It's when you start storing extra stuff that creates the problems for doing queries. So basically, that's the bottom line. Okay, let's kind of walk through an example here, and I don't think I'll put that down. So if I had, I've got my tables here. No, that's that. Okay, where's my, oh, I've already got them in here. All right, so here I'm going to, these tables I have here, right here is the example of my tables that I, uh-oh, I got make a little change here. Let's do a tiny N. I'll do a tiny N. And what else? Tiny N. Alright, see? Okay. Okay. Alright, so this is a little high level database. We're going to check to see if things go together like we think they should. So first of all, I'll create a new database. And pull that down to look at the sheet. Control C. Okay. Okay, there we are. And so I'm gonna call it Premier. And I'll just take all the defaults, say okay. Okay, so here I've got Premier database. So I go back to here, and I'm gonna do Premier database. And I think this looks pretty good. Let's go for it. Okay. It says everything completed successfully. Let's see. Sure looks good. Okay. So what we do now is we'll do a little about a new database diagram. All right, don't have one. Let's get. All right, so here I'm going to go and let's do this. Okay. And say add. And looks like we're done. And then here's our diagram. So this is my very high level design. Now I can look and say, does this look like my ERD? Okay. So here we have our sales rep. Okay, he's got the primary key. They use the little double zeros in the end there to mean many. That replaces my crows for it. And here I've got the primary key. That's the foreign key. And here's my orders. Okay, customer and orders, order line, and departments. Okay, if that matches this is my thinking over here. Does that match my thinking? If it doesn't, oh, I've got an extra, where have I got an extra
Yeah,
line?
you need sales reps going to orders.
Sales reps and orders.
Well, those are alternate lines.
No, I didn't, no, we said, I looked at my thing and this is alternate. Because it looks like what I did was what? It was this implementation here, wasn't it? You got a sales rep,
Okay.
work with them. Huh? All right. So, I like that and I don't like this now, okay? I'll change that. It's easier. Yeah, if we decided that's the way it would really be, then we got to go back and do a little extra work, okay? So, but I'm not going to do that here. Just kidding. All right. Any questions? Let's see what else I can do. I'll put these out there on iDrive so you can. I don't think I got those out there yet.
No,
They're there. Okay, I'll put them out there. So you get a feel for that. Okay. Any questions? As I said, this is not going to, this whole thing is not going to make you, database model or anything like that. At least gives you, you had to do a little small one, you get the idea of how you want to go about it. And then the next process would be, okay, what do you want to store in these tables? And then you start, filling those things in. then you just drop those tables and create the new ones. It should come back and get the same thing. Okay. Any questions on that? Okay, how about some practice? Yeah. Okay, database design. Well, this one's got a little more stuff to it than the one we did. Okay, so I've got a small college here. Okay, it's got several schools, and that's a term we might use for you know, our major divisions here. Other places might call it the School of Business and the School of Engineering and the School of Math or something like that. Okay. Each school operates several departments. So each school would have different departments. If it was like engineering, it might be electrical engineering, civil engineering, something like that. Or it's the science school, School of Science. You know, it could be chemistry, maybe geology. Maybe math gets stuck in there. Each course, okay, let's see. Each department offers courses and has students in the department's department study programs. So we now know that you know, our departments have a lot of courses, or a set of courses, and the students can have participate in the study program. It's called like a major. Okay. And then each course generates classes which are taught by a professor in which students enroll. Okay, that's loaded too. Okay, so you can identify with that. We only have one class in SQL. I got an SQL course. We offer one class. I got a Programming Fundamentals 1 out here. Okay, that's a course. I offer 2 sections of that. It's 2 classes. We're talking about Chemistry 101 or Economics 101. They probably got 50 classes. One course. Okay. And okay, so we got taught by a professor in which students enroll. Okay, so student enrollment in the class. Okay. A professor is the employee of a college. Okay. Nice. And is assigned to a department. It's like I belong to the computer science department. He will advise many students, and he also may chair the department. Okay, and they don't have this scheme here, but you know, the school I went to, as soon as you enrolled in a major, they assigned you to a professor, and so when you actually, you know, you go to that professor to get your schedule of courses figured out, and then rather than go to these fly-by-night advisors they have here.
Oh.
Okay. Well, they've been giving some bad information lately, okay, or bad advice. So, wow, this is tough on professors, but ERD diagram for this small college. Create the tables with the appropriate constraint relationships and generate the resulting database diagram. So what I want to see from you is a database diagram.
You don't need to see our drawing or anything.
No, it should, you know, whatever you conceived in your mind, I'll assume that matches. Okay? Okay. And then you're, as I said, looking at things, I don't need to see your table create statements or anything. So, the database diagram really is pretty informative when we look at that. Okay? It tells me those fields. You know all you're going to be doing. Okay, you're not going to say what's going to be in there. you're just going to have, you know, a primary key and a foreign key if it's appropriate. Sure.
Considerably, how many tables do you take up?
I would say maybe 8, 7, 8.
So we don't have to put the table crate.
I don't, you have to do table create in order to get that.
But you said you didn't want to.
I did- Pardon?
You said you didn't want to see the code.
No, I don't have to see it unless you just want it. Sure. But I want a diagram.
Sure. Do you want it just real high level, or do you want a whole bunch of information?
No. I don't want anything more than what you see right here.
So we turn this diagram.
Turn in the diagram. It's gotta be a database diagram, not something on the back of an envelope. Okay?
20 post-it notes all the way.
Unless some of you are really into, in fact, your case, you ought to probably, you know, do this in a modeling tool and show me that too. I thought you were business. Who's the other one? Hillary. Huh?
I'm a marketing analyst.
Oh, you're, oh golly, you're weaseling out of it already. Okay. Oh, you don't? No, you would, normally you're not gonna do stuff like that, okay?
You get extra credit for radio.
Yeah, I would consider that, you know, if it's, you know, something substantial.
What tool do you use?
Oh, there's a lot of them too. You'd have to be probably, actually you can use Vizio. Yeah, Vizio, but I wouldn't waste a lot of time on that unless you just want to learn how to do that. That's normally what they use for that. But, you know, we're kind of simulating that. What's important to me is how do you translate this thing we got on the board into something like that? That's what's important. Because this is the kind of stuff that helps you do querying. That's basically what you're in here for. How do I do queries? How do I have a better understanding of doing queries? Okay? So you ought to be looking at somewhere around 8 tables. 3 tables, no. If you got 15 tables, you got really carried away. Okay, so think about it. What are those entities in there that are discussed? You know, not going to be something that you just roll through. You got to do some thinking. Okay.
And you are gonna put that example there.
I'm going to do all of that. Yes, I'm going to do that right now. All right. So let's well, let me see where I've got all my stuff. Okay, desktop. Premier products table. Copy. Let me, since I was right there on that spot, let me go down here to the iDrive. And SQL. And I've got the handout page. Okay, so those tables in there, okay, the tables text. Okay, yeah, that. Give you that, and then of course the description of the problem, that's in the PowerPoint. You got the PowerPoint. And then the very last thing we got to get here is we got that solution that's in the data model. Okay, we're going to program set. Copy. And all right. All right. I think we got everything. And then starting next week, we're going to procedural SQL, sometimes referred to as transact SQL. That's where we actually say how we're going to do something and not what we want done. So we got to do the work. So It'll be a little bit of different approach, and we'll eventually use that in order to write storage procedures, functions, and traits.
What chapter is that?
Oh,
Chapter 9?
probably, yeah, that's what it sounds like, but it's got to have the procedural constructs in there, or sometimes they'll call it TSQL or Transact SQL. Right.
14.
14. Thought 9 was a little bit early.
9 is what?
Yeah, that was the data model. How to code scripts. Yeah, that's
13.
it. Yeah. Execution of scripts, temporary tables, control construct. Yeah. And I'm gonna expand on that a lot with my lecture notes. That this is a little light on that.
After instructions, you say, table create ADL statements, you said earlier, you can show it to people.
Yeah, that's fine. If you just turn in the database diagrams, that's fine. But you're gonna need to do the DDL in order to get the diagram.
Right.
Okay. That's why I said I don't need to see those.
So you don't need to see the source code, just the database.
It should be on a SQL server, so, don't concoct up some crazy thing. Gotta generate it from the SQL table create statement. Okay? Any other questions? I'm done.